Welcome back to my lecture on the conceptual model in a contaminated site. We just talked about modeling, and we'd also realize some transport model. But as I mentioned at the beginning of my talk, it's important also to have some independent data which can confirm you that your model in terms of conceptual or numerical model can be affordable, can be useful for your purposes. So we can look for some additional clue. And the clue I want to introduce you is about the compound-specific isotope approach. As you know from previous lecture, is a techniques that can really help in terms of characterization of the groundwater flow, and also in terms of identification of the sources of your pollution, and sometimes also about the attenuation process and the ongoing process in terms of degradation inside your aquifer for some classes of contaminants. In detail, we can use this isotope analysis for validate our conceptual and numerical models. We use, as I mentioned before, the environmental water isotopes to identify sources, flow path, and age of groundwater. And we also realize some investigation on nitrogen compound, delta 15 nitrogen and delta 18 oxygen for nitrates, and delta 15 nitrogen for ammonium, to understand the source and fate. And we also have the possibility to analyze the chlorinated solvents, and in this case we analyze the delta 13 carbon and the delta 37 chloride for 1,2-DCA, one of the compound, the main compound found in groundwater in the class of chlorinated solvents. About water isotopes, I mentioned before that they really help to verify the sources of groundwater, and at the same time by multi-level sampling what's happened with depth about our system. So for example the water, the marine intrusion. But looking at some additional information, we treat also the nitrogen pollution, and in this case we also verify that nitrogen pollution is widespread into the aquifer with a special concentration in the western and eastern part, and both the main species have been found, the nitrates and also the ammonium. What can be the sources of these contaminants? There is a fertilizer plant into the big petrochemical plant, which of course was the main source for the nitrogen into the groundwater system. But at the same time, there are also some sewage system and water treatment from the surrounding cities, and in this case we can also verify if there is some losses from these pipelines addressing the water to the sewage system, which is also inside this big petrochemical plant. As you know, there are some graphs that can help us to identify the source of nitrogen compounds, and this is a very famous graph you probably saw before, and you can see that there is a field for synthetic fertilizer which are produced in this area, in this plant, and of course organic matter and manure, septic tanks and sewers area fields. At the same time there is a denitrification probably line along this arrow. The first sample we had in our system are related to integral sampling. So we sample water from long screen monitoring well, and we saw different situations which lead to identificate a sort of denitrification activity inside the aquifer. This is of course for nitrate. If you look at multi-level system, as I mentioned, is an additional information which you have to take into account in such a complex site. we can see that the situation is a little bit different. We have, in some cases, you can see the different color indicate different sampling, and the number indicate the depth of the sampling inside the multi-level system. By the multi-level samplings, we clearly identify the possible source, a couple of possible sources of nitrogen in the aquifer. One is related to manure, septic tanks, which could be related to the sewage system, of course. And the other one is related to the area of the synthetic fertilizer. And both of them are clearly affected by denitrification. And this denitrification can be more powerful in the shallow system. As you can see, for example, for this yellow sample, which is very affected, largely affected by denitrification, the shallow sample is more depleted, enriched than the other two. But the same situation you can see in some other less clear, but in some other sample inside your system. So we can conclude that there are some the effect of the nitrification, and the source of nitrogen can be doubled by, you can see in detail what's happened in the area where the denitrification, in the field where the denitrification is very important, is very strong. What about ammonium isotope results? The ammonium isotope results, you can see on the left the concentration in milligram per liter, which are very close to the possible source area, the treatment plant, the post-production of agricultural fertilizer, the treatment plant related to urban sewage. And looking at the ammonium isotope results, it's very clear that we can also identify some denitrification trend, but at the same time we can also identify the possibility that this ammonium can be related to a double sources also in this case. The main source can be the fertilizer, of course, but something can happen about the sewage system too. So we can identify the sewage system, which are close to zero in terms of delta 15 nitrogen for ammonium, and we can also identify the fertilizer source, which can be really enriched in the ammonium delta 15, indicating the possibility to arrive from the fertilizer. And we also identify the possibility that we have some anammox reaction inside this site due to the microbes, which can act to justify the presence of the ammonium and nitrates in the same site. What about the nitrates? This is the concentration map of the nitrates in groundwater, and as I mentioned this situation is very clearly connected with the possibility to have double sources, two sources of nitrogen. One is related to the agricultural area, another one is very clearly related to the sewage system, with some hotspot located in other areas. So the nitrogen isotopes can help you to identify the process and the sources of the of these contaminants in groundwater, and also to explain why in some area the pumping wells are reclaiming high percentage of nitrogen compound. It's an improving of your conceptual model. Moving to the last type of isotopes, we also analyze in the eastern part of the petrochemical plant the contamination by 1,2-DCA, which represented the most representative chlorinated solvents in this area, related to more than 97% of the concentration in chlorinated solvents. So we can use the 1,2-DCA for this water isotopes investigation. If you look at the integral depth sampling, also in this case we can compare the results from the long screen piezometer and of course the multi-level piezometer. If you look at the integrated depth sampling, we can see that in terms of several compounds, the most significant, the most representative are of course the 1,2-DCA, which is highly diffuse in this site, and where it's possible the vinyl chloride, which of course can arrive by biodegradation of this 1,2-DCA. If you look at the situation in terms of concentration in the source area, we can see that very high concentration are found in the source area, and the isotopic value reflect the composition of the manufacturer 1,2-DCA. But at the same time, there is some the enrichment factor, of course, in the 1,2-DCA, which means that there is some possibility for natural biodegradation, and of course this area is represented by value around ranging from -12 and -21 in terms of delta 13 carbon. As you can see, there is a comparison between the higher concentration and more depleted value, and little bit lower concentration and less depleted value. What about the multi-level sampling? By multi-level sampling, you can identify different situations in this case, because you can identify a stratification also in terms of isotopes. Delta 13C carbon is different with depth in down gradient monitoring wells and up gradient monitoring wells, which means that there is a difference in groundwater flow path, and the physical barrier really separate two different worlds. One is related to the pumping activity, and the value can be more depleted, and another one is related to the stagnation zone, so a portion of the groundwater which has been isolated down gradient. A graph taking into account not only the carbon but also the delta 37 chloride really identify with depth different situation. At the maximum depth, the value are more depleted, and the enrichment factor, interesting, the 1,2-DCA is clearly evident moving in the shallow system. This means that the biodegradation factor are very high in this situation, in this well, and the chloride are very enriched, and chloride and carbon also are very enriched, which means that biodegradation appear from the deeper part of the aquifer going in the shallow part of the aquifer. So we can identify a degradation pathway from the deeper part to the shallow system, and also a degradation pathway from the down gradient area to the up gradient area. The groundwater close to the pumping wells has an enrichment factor and a degradation pathway very clear in terms of chlorinated solvents. As you can see, the concentration of the system of the delta 13 is different. In the source area we have very depleted value, we have intermediate value in this central area, and we have enriched value in this area where the biodegradation rate is high, and the hydraulic barrier and of course the physical barrier act to separate the groundwater flow. So we can state by this sketch that the stagnation zone really exists by the use of the carbon isotope in chlorinated solvents. So we can see that the monitoring well located up of the physical barrier close to the pumping wells has a very depleted value in terms of delta 13 in 1,2-DCA. But if you look at the down gradient monitoring well, you can see that there is some difference, because the stagnation zone identify a negative value which is not similar to the deeper value in delta 13 carbon, because this area where the groundwater flow is collected, clearly influenced by the pumping wells and also by the seawater intrusion, there is a high rate of degradation in the delta 13 carbon. So the use of this type of isotope can also help us to independently validate our conceptual model, which, as you remember, is based on this stagnation zone. So, as I mentioned, the isotope value can really help you to verify your model and to validate your conceptual model without using or independently by the use of the numerical model. This is very important in my opinion, and is a strong confirmation of the validity of your results. And we are ready to go to the final part of the lecture.